Emission System Test 10. We're talking about EVAP and EGR systems. Okay, somebody tell me what
Carbon.
the EVAP system is for. What do we use the EVAP system for? And what do we use the EGR system for? Why do we even have EVAP and EGR? Would the car run without EVAP and EGR? Does every car have EVAP and EGR? Every car that's around nowadays?
Yeah.
No. Some cars don't have EGR.
Well, that won't take about much for.
Some cars do not have EGR. Your truck had EGR when it was running before you burned it up. All right. And what about, that was it, and it was a diesel. All right, now, what about EVAP? What's EVAP? Somebody tell me what EVAP is.
Evaporates fuel.
Evaporative fuel system. What's it for?
I tried to say back and forth.
Yeah, what I'm going to try to do is I'm going to give each one of you guys an assignment, and you're going to have to get up in front of the class and explain a particular system. Like I'll give one of you the fuel monitor, one of you the EGR, one of you the EVAP, one of you, this kind of thing. So you can get up and do a speech. You can do that, can't you? Didn't you take speech?
To take speech class, I'm not doing any more speeches.
Yeah, speeches are something you're going to have to do from now until whenever. All right, so let's look into this. And EVAP system is for the purpose of what? What are we controlling with the EVAP system? Hello? What are we trying to prevent? It's all about the air. It's all about smelling. It's all about poison. It's all about what?
Like the fuel smell getting into
The vapors, yeah, hydrocarbons, basically, that's what you're talking about. What about EGR? What are we preventing with EGR? What are we taking care of? What does EGR do? Why does it do it?
It's old. Don't do it old. The exhaust smells.
No, you're not going to smell the EGR issue. You're not going to smell anything, but there is poison gas, oxides of nitrogen, right? You remember that? Oxides of nitrogen are formed. Where do the oxygen and the nitrogen come from that bond together at over 2,500 degrees to make the oxides of nitrogen? You have what in the air? This air we're breathing is what?
Oxygen,
And
carbon dioxide.
there's a little bit of carbon dioxide, but it's such a tiny amount you can't even hardly measure it. If you take 100,000 molecules of atmosphere, random sample, 35 of those are carbon dioxide, and one of that 35 molecules is man-made. See where I'm going with that? Okay, but 78% of that air is nitrogen. All right, now where have you heard nitrogen mentioned? If you were to check the air in the tires on a NASCAR car going on the track, you'd find nitrogen in those tires. They put nitrogen in the tires. At the GM dealership and in some of the others, they got actually stations for charging tires with nitrogen. They pull every last bit of the oxygen out, they put nitrogen in there.
Why?
The reason they do that is because the tires last longer. Also, whenever you're driving down the road with regular air in the tires, the warmer the tires get, the more pressure they get in them. Nitrogen doesn't do that. There's several reasons for it, but the tires don't seem to dry rot as bad when they got nitrogen in them, because you always got molecular bleed through of the oxygen and the nitrogen coming out of the tires. As the oxygen comes out of the tires, just molecular bleed through, it's going to cause them to dry rot. They don't do that as bad when you're running nitrogen in them. But it's really expensive to get nitrogen put in there. And if you ever have a low tire and put even a little bit of regular air in there, then you've blown your whole nitrogen charge, right? So they use high gas bottles at the pit. When I was in the pit at the Craftsman truck race over there, I noticed they've got big bottles look like oxygen bottles, like for the torch, with nitrogen in them, and they use that for their impact wrenches. They don't have an air compressor down there in the pit. They use high pressure nitrogen gas in a bottle for that. All right, so what's the substance used in a vapor canister to absorb volatile organic compounds? Incidentally, oxygen and nitrogen mixed together over 2,500 degrees. EGR cools it off by putting inert gas in there. That's what it's about. What's the substance used in a vapor canister? What is it? Is it carbon? That's good. Good answer. Which EVAP valves are normally closed? Canister purge, canister vent, both canister purge and canister vent, or neither canister purge nor canister vent.
Canister vent valve.
That's not normally closed. Okay, that's it. You guys got to go back to school. All right. Now, this is your canister right here. Right? Okay. This is your engine right here. Okay, the engine is going to pull out of here. And on this up here, you have a vent. All right, your gas tank is right here. And the vapors from your gas tank make their way through a little hose into here. And they get stored in here. All right, in here, you've got a little solenoid valve. And right here, you got a little solenoid valve. And that solenoid valve, when the PCM operates that solenoid valve, opens it up, and usually it'll do it going tick, 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 tick. It doesn't just open it up solid. It goes tick, 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 tick. It's got a pulse width so that it can vary the amount of purge. All right, it's going to pull these gasoline vapors that came through this line into the engine and process them and burn them so they never see the light of day, right? All right, now this is ultra simplified. Okay, also in here, we've got a pressure sensor in the gas tank. Occasionally, the PCM wants to close this, and it wants to apply a little bit of pressure, or not pressure, but reduce the pressure in the gas tank. And this one's normally closed, this one's normally open. So it closes that one, opens that one, then it closes that one, and it traps that little bit of vacuum in the gas tank, and it's a tiny little bit, it's not very much. It doesn't do this unless you're parked, typically. Sometimes it'll do it whenever you're between 50 and 85% gas when you're driving. Depends on the system, everybody's got a little bit different. And they're also got some natural vacuum NVL systems that just depend on the gas to cool down and reduce the pressure in the tank and open a switch. That's a different deal. One way or another, this one's going to be closed only when the PCM is checking to see if there's a leak. All right, this pressure sensor, let's watch this. Let's draw a graph here. What if the pressure sensor did this and then it leveled out whenever this thing stopped? Now you got leak detection pumps on some of the Chryslers and all this. There's a bunch of different ways this thing works. So we're going to assume we're doing the one with the engine running. All right, this right here is supposed to hold. It's not supposed to leak back up. If it leaks back up, when it's holding this, measuring that, and holding that, after it has delivered a vacuum, it leaks back up, it knows it's got a leak, and it throws you a PO 455 if it's a big leak. It'll throw different codes. Well, when it releases this, it expects it to go back up. If it doesn't, it throws you a code for that. Because sometimes this gets clogged up with dust and stuff, or the canister itself might be. That's why most of your canisters nowadays have got a filter. But that vent right there, whenever this air is pulling in here, the air is coming in there and going purging the canister. And that's how that basically works. Now, years ago, back in the way yonder, I think they started in the early 70s putting canisters on cars. I don't know exactly when it was, but the fact was I've seen them for eons, even when we had just Chryslers. The old EVAP system only purged the canister when EGR was flowing. And then later on they started using a little solenoid to do that. So keep that in mind. That's what EVAP is all about, right? Now, what is the significance of EVAP? It can cause drivability problems. We talked about that a little bit yesterday. All of the following can increase the pressure in the evaporative system except A, returned fuel from the fuel injection system, B, fuel temperature, C, volatility of the fuel, or D, inlet fuel to the fuel pump. Returned fuel from the fuel injection system means that you got a fuel pressure regulator on the rail. Fuel goes up there, the excess pressure lifts that regulator off its seat, pressure comes back to the tank. Could that increase the pressure? Because it's going to be warmer when it goes back than it was when it went up, right? Fuel pump pushes it up there, it's kind of cool, comes back, it's warm, so that can increase the pressure, correct?
Yeah.
Yes or no? Okay. All right, and then what about fuel temperature? When fuel gets warmer, does it increase pressure? Hello?
Yeah.
All right. Volatility of the fuel. If it's more volatile, we talked yesterday about read vapor pressure. If it's more volatile, is it going to be prone to increase pressure just because of the nature of it to,
Yes.
all right. So inlet fuel to the pump, is that going to do anything to increase pressure? No, if anything, it's gonna reduce pressure because it's pumping fuel out of the tank, right? Okay, so D is gonna be the right answer on that one. Number 4, evaporative emission control systems operate on low pressure measured in inches of water. 1 PSI is equal to how many inches of water? That's a good question. Oh, wow, listen to that. How did you know this? Huh?
Smart like that.
He's got to come up with a better answer than that, doesn't he? Where'd you come up with that? Was it a wild guess and you just happened to get it right? Where'd you get that information? What's the first thing you ever remember learning when you were a little kid? The very first thing. You either learned it or somebody taught it to you. What's the first thing you remember learning?
I can't even remember what I ate yesterday. How do I remember that?
Now I learned how to ride a bike.
That was a good answer.
Say no to how many cookies I'm supposed to eat.
Yeah. All right. That's what I want to know. But I didn't know. I knew you didn't learn about this. This particular thing. 1 PSI is equal to how many inches of water? Wow. 2, technicians are discussing a state emission test. All right. Technician A says a vent valve is not able to close. That is not able to close can cause the system to fail the onboard test. And that's actually the test I was just giving you a rundown on. Technician B says a leaking gas cap can cause a failure of the EVAP test.
Both.
Both of them are right. I told this story a while back, but the service manager came out there when he was about like 5 till 12. And he says, I know you're about to go to lunch, but there's a Lincoln out there in the service area, and if you'll go out there and troubleshoot the check engine light, I'll pay for your lunch. So I went out there and plugged the tool in, tried the check engine light, got a PO 455, went back there, found a gas cap loose, tightened it up, cleared the code. And it was like 2 minutes to 12, and I said, okay, Roger, where's lunch? And he didn't buy a lunch for me, because he figured I didn't deserve it because I didn't use any of my lunch hour doing that. I didn't care. It wasn't bothered me. I had money for lunch. But anyway, a PO 455 code is usually going to be a loose gas cap. However, a lot of these cars nowadays have got a little light on the dash that shows a picture of a gas cap removed. You have one of those? Mine does. If it knows that the PCM can look at the fuel level in the tank, because it will not measure check the evaporative system unless he's got more than 15% or less than 85% gas. If you got it all the way full or all the way empty, I don't know when the last time my wife's Explorer has had the evap system checked, because she keeps that thing banging on full all the time. She will not let it get even a little bit down before she puts more gas in it, or has me do it. But the simple fact is, and that's not a bad thing, because you don't get moisture that way, because there's condensation in the tank. It'll get moisture down in there. But one way or another, you put that code, check engine light, let me back up, gas cap light. It saw that you didn't have a lot of gas. It saw now that your gas is full, and now it's got a big leak. Not much to figure out that you filled up the tank and left the gas cap off. So it's got a little picture of a gas cap that's not on. And that's basically, it's a gas cap light. That's what it is, fuel cap light, whatever you want to call it. My car's got one. Let's see, wait a minute. So number 5, yeah, you're going to write both. Which evap valve is subject to rust and corrosion more than all the others? The vent valve, and it's because it's pulling moisture in there and everything else. I always suspect that vent valve is a problem. On some of these Chevrolets, these late model Chevrolet pickup trucks, they use vent valves. They go bad quite a lot. And when you're doing a smoke test, you remember that worksheet where you're supposed to get your scan tool, close the vent valve, and pump smoke in there to see where it was leaking at? And that's basically got if the vent valve won't close, if you've closed the vent valve and you know that the electric wires are good going to the vent valve and there's smoke coming out of the vent valve, you probably got a bad vent valve. You can also have a bad canister purge valve that'll throw you codes like that, split hoses, that kind of thing, or somebody put a fuel pump in it and didn't put the lock ring down with the gasket good and all that kind of thing. I've done that before. I've seen that. Truth to tell, I've probably done it before too, but I don't remember when. All right, so before an evaporative emission monitor will run, the fuel level must be where? I've already been saying that over and over. What is it? Now, 15 and 85% is the right answer. It says
What?
evaporative emission monitor, it says 15 and 85%. Between 15 and 85% is what I've heard and been taught all my entire professional life, even before I came here to teach 15 years ago. I was taught that. Now, this particular test is claiming it has to be at least 75% full. Unless that has changed and I didn't know it, I would say C was right. If I was taking this test myself, I would put C, and I would argue with the person that administered the test. Now, they're saying it's got to be at least 75% full. Now, since my work study student is so studious to grade these, make sure you circle A, but in the real world, I've seen 15 to 85%. I don't like that answer. It's probably wrong, but we're going to go with it because we don't want you getting that question marked wrong. Technician A says low pressure smoke installed in a fuel system can be used to check for leaks. We've all used a smoke machine this semester, I hope. Technician B says nitrogen under low pressure can be installed in the fuel system to check for leaks. Which one's correct about that? That is C. You can use nitrogen. I've used nitrogen. We had a system for doing that when these things first came out, but that is a really lousy way to do it. Because what they would do is they'd have you pump nitrogen pressure in there, and they'd have you use a little sonic leak detector that could hear the hissing of the nitrogen coming out, and you would run it down there, and if it went, wee, you know, it's almost like checking for a refrigerant leak or something like that. I never have liked that. They also had a sonic leak detector. They had the idea that if you filled the system up with sound, then the sound would be leaking out the little hole. Think about it. Yeah, I'm serious. They had a sound generator that would put in there that and it would fill the hole. If you consider this system being like a big cavity, and that just didn't fly. And what works better than anything else is the dadgum smoke. Smoke works better than anything else for finding evaporative leaks, and sometimes they're hard to find that way. Guess when you gotta have a bright light. Let me see, small leaks detected by the evaporative emission control system monitor. It could be caused by a loose gas cap. Which code will, this is a small leak now, not the big leak like I showed you up here. Which DTC will likely be set? That's going to be B, PO440, PO441, PO442. Get used to those. The PO400 series codes have all got to do with air, basically. You know, like a PO401's EGR and this kind of thing. What causes the nitrogen and oxygen in the air to form NOx?
Heat above 2,500.
Heat above 2,500. I'm glad you burned that in. Did everybody else know that? Quincy, I did not hear from you. You're supposed to be smart like that. Hello?
Yes, sir.
All right then. Exhaust gas recirculation is not generally needed under any of the following conditions except, anybody know?
Idle speed.
Cold engine?
No, cruise speed.
Yeah, exactly. You're cruising down the road, that's when you need EGR. You don't need it wide open throttle. And also, you usually, on most vehicles, except some of the really new ones, I think, you just about always drop an open loop fuel control at wide open throttle too, because you don't want anybody jacking around with your fuel mixture when you're passing a semi going up a hill. You know what I mean? That's the last thing you need. All right. Okay, so, let me see. I don't want to mess up here. Okay, Technician A says, a low restriction exhaust system could prevent a back pressure type vacuum controlled EGR valve from opening. Now, that is true because I have seen that. Technician B says, restricted exhaust can cause the EGR valve position sensor to fail. Who's right about that? Both those guys are right. The EGR valve position is measured in a number of different ways. Let me ask you this. If you were an engineer and you were getting paid the big bucks, and they says, the EGR valve opens, all right, here's your EGR valve, here's the heart of it right here. You've got a seat right here, basically a hole, and you got exhaust coming up here because you got a pipe screwed on there, right? You have a pintle. You got a diaphragm or a motor or whatever that opens that. When you open that, that exhaust is going to be able to leave this pipe that's coming from the exhaust and go into the intake. But it's only supposed to happen when this valve is open. Now then, you're the engineer. We need to know how we can tell if this EGR is flowing. I need to know how it's flowing. I need to know how, is it flowing or is it not?
I don't think it is.
No. How would you be able to tell? That's what I'm asking. You need a system. You got to design a system so that I'll know I can hook it up to the car In other words, I can type algorithms into my PCM. The PCM needs a feedback mechanism so it can tell if EGR is flowing or not. So how are you going to do it?
A sensor,
Huh?
a sensor,
Where are you going to put it? That's not a bad answer, but where are you going to put a sensor?
probably,
I've done this one time. Oh my God.
You did not.
Did I have?
This is the first time I've done this, ever. You slept, you dreamed that.
Like for real, I'm dead serious. Cause remember, it was a car. We took down the road. It was like a grab thing.
Well, I know that, but what I'm trying to say is you got to come up with a system. I'm talking about engineering. I know you've troubleshot an EGR before,
Yeah.
but
I
listen,
would say underneath the EGR.
you're going to underneath it. Okay, so here's our pipe right here. We got a pipe screwed onto this. I got to draw that better. All right, and that pipe, that exhaust is flowing up here. So now, what are you going to have that sensor sensing?
Is it oxygen?
Air
or-
coming up,
You mean the pressure?
yeah.
Okay, so if this is closed, there's going to be pressure there all the time, isn't there?
Okay, then above it.
Okay, so above it. So we're measuring pressure above it. Okay. So we're going to put, there's our diaphragm right there with a vacuum line hooked to it, if that's the way we're doing it. And this is going to be connected to the diaphragm. When low pressure comes in above the diaphragm, it raises the pedal off the seat. All right, so we're going to put a sensor right here. And we're going to put wires coming out of it, right? And this is going to be a sensor that reads pressure. We don't really have a lot of room. We can put one in there. It's got to be down here so that when the exhaust is flowing, it flows past it, right? Now, there is, on the Asian cars, they've done that. And what they use is a temperature sensor. So what happens, that exhaust is hot, right? All right, so if you put a temperature sensor in here and it gets really hot, you can tell that EGR is flowing. If it doesn't get really hot, you can say, well, the EGR is not flowing, I'm going to turn on a code. I'm going to turn on a PO401. Okay, now, another way, I'll tell you how the way the Ford people do it. What about, let me ask you this. What does your oxygen sensor do when EGR is flowing? Wouldn't that be a good feedback? Is it going to change? If you're watching that oxygen sensor real close, if you're the PCM, you're watching the oxygen sensor and say, I'm going to deliver a little EGR. I'm going to raise that pedal. I'm going to deliver some vacuum. I'm going to raise it up. And I'll be able to look at that oxygen sensor and tell if that thing's flowing. So what's the oxygen sensor sniffing? Oxygen. You won't have as much oxygen, will you? Because you're displacing some of it with this inert gas. So you're going to probably see it drift up a little bit. I'm surmising. GM did that for years. All right, but Ford did this. Here's what Ford did. Ford took and put a little restrictor right here. And they put a hose right here and a hose right here going to a sensor with 3 wires to it, reference voltage, signal, and signal return. All right. These hoses were 2 different sizes. All right, when exhaust is flowing in this tube, what does the pressure here in front of this orifice do? Imagine yourself with 2 gauges connected to it. What does the pressure on this side of the orifice do? The engine is pushing exhaust up this way. What do you think it's going to do? What happens when you put your finger over the end of the hose? The hose gets tight, right? Okay, so this pressure on this side is going to go up, and the pressure beyond the orifice is going to go down. They call that a DPFE, delta pressure feedback EGR. If it doesn't see that change, it knows there's no exhaust flowing. If the passages are stopped up in the intake with crud, which a lot of the times they will be, then you won't have any kind of EGR flowing through there. All right. Here's another thing that we like to do. Let's get rid of that right there. And get rid of that. We're just going to have an open pipe. All right. Some of them, well, like the Bronco out there, it's got a linear potentiometer on top of it. And it's got a little thing sitting on top of that EGR valve, and it's got VREF, and it's got signal return, just like all the rest of them. It reads about 0.4 of a volt when EGR is not flowing. And as this raises up, that voltage goes up, and it knows that it's raising that, but it knows the feed, it's got a feedback mechanism telling it, how much it has opened the EGR, but it still doesn't know if it's flowing. You see what I'm saying? This is what engineering is all about. These people have got to determine what's the best way that we can tell if EGR is flowing or not, so that the PCM can decide to throw a code or do whatever, or maybe open it a little more or something like that. The most common problem that you have with EGR is it actually clogs up the ports that this stuff flows through there because of PCV steam condenses and turns into tar in the intake and all that hogwash. So I wanted to burn that in. There is a worksheet that I gave out on EGR system familiarization and emissions. You remember seeing that? Everybody should still have it. If you don't still have it, woe is you. You need to come up with that. EGR is extremely important. Okay, let's keep going. Some of them don't have it because they don't need it. Some of them don't have it because they close the exhaust valve early whenever they're wanting to trap some, that's variable valve timing on the exhaust camshaft used for that. Okay, what are you controlling with EGR? What have we been saying, y'all? What does EGR control?
Exhaust gas?
See?
EGR is used to control which exhaust emission?
Oh,
Come on, yeah.
CO2?
NOx.
Oh.
NOx. I can't believe you guys didn't remember that. I just hammered on it a while ago. Oxygen and nitrogen hooking together. A typical EGR pendle position sensor, which I just drew one up here, is what type of sensor? What did I say? What did I say?
P.
Potentiometer. Linear potentiometer. OBD2 regulations require EGR system be tested. Technician A says PCM can monitor the commanded position. Technician B says PCM can open the EGR valve and monitor it for a change in map sensor reading. That's another way. The pressure in the intake is going to drop when EGR starts to flow. So that's going to be C. Two technicians are discussing clogged EGR passages. Technician A says clogged passages can cause excessive NOx emissions. That's obviously going to be true. Technician B says clogged EGR passages can cause engine ping. Why? Because of the coolant, the temperature is all that. In other words, the temperature in the combustion chamber goes up above 2500, you're going to make NOx, right? And you also got pinging and detonation, which we talked about a couple of days ago. EGR valve that's partially stuck open would most likely cause what condition? Remember how I've shown you that? When you open the EGR valve, what does the engine sound like?
Rough idle?
Rough idle, bingo. When testing an EGR system for proper operation using a vacuum gauge, how much should intake manifold vacuum drop when the EGR valve is commanded to open by a scan tool? You may not know that, but 6 to 8 inches is something you're going to see on that if you hadn't read it. PO401 DTC is being discussed. Technician A says a defective EGR valve could be the cause. Technician B says clogged EGR passages could be the cause. Both of those guys are right. And finally, number 20, following statements are correct except A, OBD2 vehicles require monitoring of the EGR system. Is that true?
No.
Yes,
No.
it is. OBD2 does. Mill will be turned on after the second failure. Is that true?
I thought it was just the first failure.
Huh?
I thought it was the first failure. Oh, second.
After the second failure. All right, that's a 2-trip failure. Linear EGR systems require exhaust piston and back pressure. They don't because they're linear EGR system. That's one that operates with a different, marches to a different number. Many vehicles use the map sensor to monitor EGR operation, which is true. All right, anybody got any questions? Anybody got any ideas? Anybody got any retorts? Anybody find anything wrong? Huh?
12.
12 is basically going to be C.
What was 2?
You guys are missing some, aren't you? Somebody tell her what 2 is.
Okay. What is
The canister purge valve is the one that's normally closed.
18?
20? Where were you at when I just did 20? Somebody tell him what 20 was.
C. D. C.
If you just use the letter, it's Charlie.
Oh. Okay.
All right.